A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today we will be talking about the types of concrete. We will define concrete, then we will be talking about the types of concrete, and then we will discuss each and everything in detail. So, anyone in the class who can tell us about the types of concrete? Uh, Hezbollah, what are the different types of concrete? Muhammad Umair? Muhammad Umair. Muhammad Umair, beta, are you in the class? Okay. Ammara Amir? Ammara Amir. Beta, are you in the class? Ahmad Tariq? Ahmad Tariq. Ahmad Tariq. Okay, Mansoor Khan.
Yes, sir.
Beta, please define concrete and then tell me about the types of concrete. What are the different types of concrete?
Yes, sir. Sir, concrete is a mixture of water, cement, fine aggregate, and coarse aggregate.
Okay.
And types of concrete is normal strength concrete, reinforced concrete, pre-stress concrete, lightweight concrete, high density concrete, high strength concrete, etc.
Okay, good. Muhammad Ahmad. Muhammad Ahmad.
जी सर जी
Beta,
सर
आवाज आ रही है?
यस सर आवाज आ रही
Can you define concrete?
yes sir concrete is a mixture of fine aggregate coarse aggregate and cement combined in a proper ratio to and form a hard structure.
Okay, Amir Hamza.
जी सर.
How concrete should be, or what should be the properties of a good concrete?
गुड कंक्रीट की सर वर्कबिलिटी अच्छी होनी चाहिए, उसमें सेग्रीगेशन नहीं होनी, उसका मिक्स डिज़ाइन सही होना चाहिए सर, सारे प्रॉपर्टीज उस कंक्रीट में होनी चाहिए.
ऊंचा बोलो बेटा, ऊंचा बोलो.
सर गुड कंक्रीट की वर्कबिलिटी अच्छी होनी चाहिए, उसमें सेग्रीगेशन नहीं होनी चाहिए, उसके वो मेल मिक्स्ड हो, वेल ग्रेडेड हो सर.
Okay, these are the properties of fresh concrete. When it becomes hard, फिर क्या होना चाहिए?
हार्ड में सर उसकी स्ट्रेंथ अच्छी होनी चाहिए, जो अल्टीमेट स्ट्रेंथ होती है उसकी, जो सुतरियस वगैरह
गुड, शाबाश. ठीक है. इसके अलावा ओके ओके अब्दुल मुनाफ इज एडिंग समथिंग, ड्यूरेबिलिटी. ओके अब्दुल मुनाफ, आप बताएं कंक्रीट में कौन कौन से प्रॉपर्टीज होने चाहिए सो दैट इट कैन बिकम अ गुड कंक्रीट.
सर कंक्रीट की हाई स्ट्रेंथ होना चाहिए सर, ड्यूरेबिलिटी होना चाहिए सर, रेजिस्टेंस टू अबर्जन होना चाहिए सर, और इसके साथ फिनिशिंग जो है सर वो अच्छा होना चाहिए कंक्रीट का.
दिस इज रेजिस्टेंस टू एब्रेशन. ठीक है, रेजिस्टेंस टू एब्रेशन, ABRASION, abrasion. Okay, so let me talk about concrete and then about the types of concrete. So today we will be talking about concrete. We will try to define the concrete. Then we will try to talk about the constituents of concrete. Then regarding some properties of the concrete. Then we will be talking about types of concrete. So today we will be talking about normal weight concrete, lightweight concrete, high density concrete, high performance concrete, self-compacting concrete, and finally the entrained concrete. And there are some other types as well. There are roller compacted concrete, shotcreting, etc. So we will discuss them as well. So concrete. Everywhere around us is concrete. I hope everybody understand this. Whenever you look around, to the hospitals around you, to the roads around you, to the buildings around you, to the schools and colleges around you, all these are made from concrete. So that's why we can say concrete is everywhere around us. Even your own house may be made from concrete, or your neighbor house or your friend house may be made from concrete. Concrete is a composite material wherein a binding material mixed in water on solidification binds the inner particles of well-graded fine and coarse aggregates. So as discussed by some of your colleagues, that concrete is a composite material. Where is a binding material? The binding material is the cement, which combine with the help when it is mixed with water due to the hydration reaction. It binds the inner particles. Inner particles are those particles. Abdul Munaf, what are inner particles?
सर
Are inner
एग्रीगेट इनर पार्टिकल है सर, क्योंकि ये किसी के साथ बॉन्ड नहीं बनाते सर।
बाण नहीं बनाते या रिएक्शन नहीं करते?
रिएक्शन नहीं करते।
जी मंसूर खान आप बता दें।
Yes, sir.
जी, what are inert aggregates or inert particles?
Inert particles, sir, fine and coarse aggregate are inert particle because ये reaction नहीं करते उसके साथ।
Exactly. Inert particles or inert aggregates are those aggregates which are not taking part in the hydration reaction or the chemical reaction. So these binding materials, which is cement, they are binds together the inert particles that are coarse aggregate and fine aggregates, and these are well graded materials. As we have discussed, we are trying to use the well graded fine and coarse aggregates. So I hope everybody will remember that concrete is a composite material which is made from the binding material, that is cement. Sometimes we can use lime as well, or cement and lime together as well. And when it becomes hard or when it is become solid, then it has already this binding material will have to binds together the inner particles. What are the inner particles? The inner particles are the well graded fine and coarse aggregates. So concrete is a mixture of cement, water, aggregates, and sometimes admixtures. Now, what are the constituents of concrete? So I hope now everybody remember that constituents of concrete are cement, that is the binding material, the aggregates, which include fine aggregates as well as coarse aggregates, water, and then admixtures. Why we are adding admixtures, Abdul Munaf? Why we are adding admixtures in the concrete?
Sir, to get the desired property of concrete.
To change the properties or to get the desired or the required properties of the concrete for which you have designed the concrete. Now, anyone in the class who can tell me about the uses of the concrete, where we can use this concrete? Amir Hamza? जी बेटा, अमीर हमजा। Amir Hamza, are you in the class?
यस सर, मैं क्लास में।
बेटा आप बता सकते हैं व्हाट आर द यूजेस ऑफ concrete? concrete कहाँ पे यूज हो सकता है?
कंक्रीट सर बिल्डिंग कंस्ट्रक्शन में यूज होता है, रोड कंस्ट्रक्शन, पेवमेंट्स, टनल, माइंस, ये सारी चीज़ों में सर होता है, रनवेज।
दाऊद खान? दाऊद खान,
जी सर।
where we can use this concrete?
सर
कहाँ
कंक्रीट
पे
को
यूज?
हम कॉलम्स में, स्लैब्स में, लेंटल बीम्स में, पिलर्स में, ब्रिजेस में, डैम्स में, बहुत
शाबाश,
सारी इस तरह
ठीक है।
जो।
तो
ओके सर।
हाँ,
जो
फजल
रोड्स है
गफार?
उसमें भी।
फजल गफार? Fazli Ghaffar, are you in the class? Okay, Jalal Bashir. जलाल,
Yes, sir.
रोड में हम कैसे यूज करते हैं? रोड में तो कंक्रीट यूज नहीं होता है। रोड में तो वी आर यूजिंग एस्फाल्ट।
So dams, bridges, building foundations,
आई एम आस्किंग अबाउट द रोड्स। रोड्स में कहाँ पे यूज होता है?
roads में
जी, रोड में। ये लोग कहते हैं कि रोड में भी यूज होता है। दाऊद खान कहता है, वही जो आपका दूसरा दोस्त है ये भी कहता है।
सर पता नहीं।
रोड में आपने नहीं देखा है कहीं?
No, sir.
ये आप जब हैदराबाद जाते हैं और स्त्री चौक से आप गुजरते हैं, वहाँ पे जो ब्रिज बना हुआ है, फ्लाई ओवर, वो किस चीज़ से बना है?
Bridge, sir, concrete, sir.
कंक्रीट से बना है। Okay, so let's talk about the uses of concrete. At where we can use the concrete. So we can use the concrete in roads. As I told you, the rigid pavements are made from concrete. The flexible pavements are made from asphalt concrete. That is, we are using the binding material as bitumen in case of asphalt concrete. But when we are using these rigid pavements, we are making the roads from concrete, from where we are using sand. Maybe you have seen in the hilly areas, जहाँ पे बारिशें ज़्यादा होती है और रोड के ख़राब होने के चांसेस ज़्यादा होती है, then we are trying to use this rigid pavements in some of the areas. You can use the concrete bridges. Yes, the bridges, most part of the bridges are made from concrete. Yeah, the footpaths or the sidewalks, the runways in the airports, they are made from concrete. Canals, these are the lining of the rivers or the lining of the canals, these are made from concrete. Mines, जो खान होते हैं, also we are using concrete over there. Tunnels, and tunnels we are using concrete, we are using shotcreting. And dams, this Warsak dam is made from concrete. Okay, then sewer pipes, the sewage line pipes, maybe you have seen, most of you people have seen the drainage system or these sewer pipes, these are made from concrete. Railway ties, and this railway track, maybe you have seen these ties which we are using uh, below the track of the train. So they are also made from concrete. Before they were using it, they were making it from timber, from wood, but nowadays they are using making it from concrete. Manholes in the sewage lines, where you can send the workers or the laborers and they can clean the drainage system or the drains. So we are providing manholes uh, for this purpose, and this is also made from concrete. In the nuclear power plants and in the nuclear installation, they are also made from concrete, and many more, vagera vagera, and many more things you can use the concrete over there. So as we discussed in the start of the class that how concrete should be, or what shall be the properties of the concrete when you are using it uh, in your house or in your project or in hospitals or in schools. So concrete should be hard so that it can resist the vibration or the wear and tear. It should be durable. It should work for a long time or for the design period of the structure. It should be strong enough to resist the load which you have applied or for which you have designed the structure. It should be highly dense. Its mass per unit volume or weight per unit volume should be high, okay, so that it may not allow the water to pass through it. It should be non-porous. There should be no pores. There should be no voids, so that the concrete should be impermeable. And the most important thing is it should be economical. Being a civil engineer or material engineer, when you are designing the concrete, it should be economical so that uh, it may not cause burden on the project or on the person who is making the house from the concrete. So we should try to design the concrete more economical, to use most of the most maximum proportion of the aggregates and minimum proportion of the cement as much as possible without compromising on these properties. Now the typical composition by volume, it varies from 7 to 15%. So when you are using 7% cement, it is very clear the concrete will be not hard, not durable, not strong, not dense, and it will be porous. although it will be economical, but it will be not having these properties. It can go up to 15%. So when you are increasing the cement quantity, you can increase some of the properties. Water 14 to 21%. So as I told you, the water cement ratio should be kept as minimum as possible. So when you are using minimum quantity of water, you are making dense concrete, you are making hard concrete, you are making durable concrete, you are making strong concrete. And the aggregates, if you remember, I told you 3/4 of the volume of concrete is occupied by the aggregates. So these are some typical composition by volume. But when we will discuss this max design, then we will have to calculate the actual value of cement, actual quantity of water, and actual quantity of fine and coarse aggregate. Now concrete versus steel. Jalal,
जी सर.
Jalal, it is written over here in USA, concrete consumption is 5 times by weight of steel. इसका क्या मतलब है?
Concrete consumption 5 times. मतलब ratio 5 for each part of steel. There are 5 parts of concrete.
इसका मतलब क्या है? दाऊद खान,
जी सर.
इसका क्या मतलब है बेटा?
सर इसका मतलब है कि इनके वेट का रेशो इतना होगा, मतलब फॉर एग्जांपल अगर 1 टन स्टील यूज होगा तो इसके लिए 5 टन कंक्रीट वो यूज करेंगे.
Okay, Sophia server. Sophia
यस
server. Are
सर.
you in the class बेटा? इसका
यस
क्या
सर.
मतलब है बेटा?
सर यही
जी,
मतलब है कि मतलब स्टील का एक हम रेशो लेंगे ना, और कंक्रीट की जो होगी वो 5 टाइम जिससे ज़्यादा होगी. लाइक अगर 1 टन स्टील है तो 5 टन हमारे पास कंक्रीट यूज़ होगा यूएसए में.
नो. मंसूर खान,
Yes, sir.
मंसूर खान बेटा. जी बेटा,
Yes,
कैन यू कमेंट ऑन दिस? जी,
sir. Same.
सेम आंसर. अब्दुल मुनाफ,
जी सर, सेम आंसर है.
अहमद तारिक, okay, in USA, because USA is the rich country, so they are using concrete 5 times more than steel, because steel is very costly. Steel is costly and concrete is cheaper, so they are using steel. They are using 5 times more concrete than using the steel. But for other countries, because other countries are not that much developed or that much rich, so concrete consumption exceeds 10 times by weight of steel. And in developing countries like Pakistan, Sri Lanka, Nepal, and all these countries, it may be more than 10 times. Okay? Because steel is very costly. It is written over here, more than 1 ton per year per person. Amara Amer,
यस सर.
इसका क्या मतलब है बेटा? मोर देन 1 टन पर ईयर पर पर्सन, कि एक बंदा एक साल में 1 टन कंक्रीट खाता है. इज इट लाइक दिस?
यस सर.
कैसे कंक्रीट कौन खाता है? कंक्रीट तो लोग नहीं खाते हैं.
सर हम लोग शायद वो सब्जियां खाते हैं, वो जमीन से आती हैं तो उस वजह से.
Okay, so people are using concrete, as I told you. Concrete is everywhere around us. So we are using this in all the structures. So people are consuming concrete per year per person is how much? 1 ton. हर एक बंदा एक साल में 1 टन कंक्रीट इस्तेमाल करता है. And man consumes no material except water in such tremendous quantities. क्या लिखा है कि only the water is the material which the people are using in such high quantities. Only water is on the higher side than concrete, because whenever you look around you will see concrete. So this is one survey that more than 1 ton concrete is used by each and every person in 1 year. ठीक है बेटा, concrete कोई खाता नहीं है. We are using the concrete so that we can make our structure from it, and we can have our life, or we can stay inside there, and we can save ourselves from the hard weathers, and from the cold weathers. Okay, we can make our offices, we can make our hospitals, we can make school for our children. All these are the uses of concrete. So is it okay, Abdul Munaf?
जी सर.
Okay, so let's talk about the normal concrete or normal weight concrete. These are the next is the types of concrete. We have discussed concrete in detail. We have discussed some properties of the concrete. We have discussed the constituents of the concrete. We have discussed the uses of the concrete. Now, for each and every project, we will need a specific type of concrete. So, for that purpose, we need to know about the types of concrete. So, the first type of concrete which we will discuss today, that is the normal concrete or normal weight concrete. The concrete in which common ingredients, that is aggregate, water, and cement are used, is known as normal concrete. As it is clear from the name, normal concrete. So, when you are using the normal aggregates, that is the coarse aggregate, fine aggregate, and water. And then you are using the normal cement in that is ordinary Portland cement. So the concrete which you are getting from these materials is known as normal concrete or normal weight concrete. It is also called normal weight concrete or normal strength concrete. It has a setting time of 30 to 90 minutes depending upon the moisture content in the atmosphere, the fineness of the cement, etc. Mansoor Khan, Mansoor Khan, Mansoor beta. Okay, Fahad Ali, Fahad Ali, Fahad Ali, Durre Kamla Saditi.
Yes, sir.
Beta, can you comment on this? Can you explain this? How the fineness of cement, how the fineness of cement will affect the sitting time or the sitting time of the
सर
cement or the sitting time of
ओके,
the
फाइननेस ऑफ सीमेंट ज़्यादा
जी
होगी
बेटा
सर, तो सरफेस एरिया ज़्यादा अवेलेबल होगा, तो हाइड्रेशन रिएक्शन ज़्यादा तेज़ होगा, तो एज रिजल्ट सेटिंग टाइम डिक्रीज होगा.
good, well done. Okay, the development of the strength starts after 7 days. The common strength values after 7 days is 10 megapascal to 40 megapascal. Uh, about 7 days, 70 to 75% of the total strength is attained. This may be this is not 7 days. This is mistake. The development of the strength starts normally just the concrete starts hydration reaction, and with the passage of time, it's getting strength. So after 7 days, this much strength can be achieved, and this is the 70 to 75% of the strength of the 28 days for which you have designed the concrete. So you will have to make concrete cylinders from the concrete, and then you will have to take this to the laboratory, or if you have your own laboratory, just go and test these cylinders after 7 days. And if you have got 70 to 75% strength or 65 to 70% strength uh, of the 28 day strength, let's say you have designed 28 day strength is 3000 psi. The design strength is how much, Abdul Munaf? Abdul Munaf?
जी सर.
Let's talk about the design strength is 3000 psi, and after 7 days you are testing the cylinders of this concrete. So how much will be the 70% strength of this concrete? How much should be the 70% strength of this concrete? If the design strength is 3000 psi,
70% सर. सर इसको नहीं दिया.
ज़रब दे दो शाबाश.
सर let me repeat.
70
अगर सर
70
डिजायर
multiplied by design strength is 3000.
70 multiplied by 100 multiplied by divided by 3000.
70% of 3000. So 70 multiplied by 3000 divided by 100. Okay, so this is almost 2100, yeah? 721. So if it is around 2000 to 2100 or 2200, then yes, you have achieved the required strength of the concrete. But it is very less. Let's say it is 1000 psi. Then it means the concrete which you have used in this project, that is not according to the desired strength. Either you have to demolish the whole structure and make it again, or you have to rehabilitate it with the help of uh, some technique which we will study in this repairing of cracks and strengthening of structures. So this is all about the 7 day strength. The gain in strength after 28 days can be taken into account in design. As I told you, the 28-day strength, when you are testing this concrete cylinder in the laboratory after 28 days, then this strength is used in the design calculation of the structure. In your higher semesters, you will have to learn these things, how you can design the buildings, how you can design the bridge, and how you can design the other structures. So the concrete strength which will be you people will be using in your calculation, that will be the strength of the concrete tested at 28 days. Coming towards the properties of the normal concrete, so its slump varies from 1 to 4 inches depending upon the type of work for which you are making this concrete. The density of this concrete varies from 140 pounds per cubic feet to 175 pounds per cubic feet. It is strong in compression and weak in tension. Mansoor Khan? Mansoor Khan,
Yes, sir.
are you in the class, beta?
Yes, sir.
Uh, it is strong in compression and weak in tension. इसका क्या मतलब है? जी बेटा, can you comment?
No, sir.
Okay, no problem. Hayat Ahmad Khan? Hayat Ahmad Khan. Beta, can you hear me? Are you in the class? Only 5 or 6 people are giving response to my questions. ये बाकी लोग कहाँ पे हैं? मोहम्मद उमेर? Okay, the CR, Saad Ahmad.
Yes, sir.
Beta, can you comment on this? It is, they are talking about the normal weight concrete or the normal concrete, that it is strong in compression and weak in tension.
Sir, it means it is non-elastic or tension may weak, sir.
Okay, Umar Hayat?
Yes, sir.
बेटा आप कुछ बता सकते हैं?
No, sir, I have no proper idea, sir.
Okay, Umar Shehzad?
जी सर.
Can you comment on this?
सर मतलब ये है कि जब इसके ऊपर लोड आता है तो वो इजीली बेयर कर सकता है, लेकिन टेंशन में जो है तो ये क्रैक्स पड़ जाते हैं सर, वीक है.
Okay, if
तो
you
उसके लिए
remember, I have already explained this in one of the class, that concrete is good in compression. When you are applying load from the top on concrete, then it can bear it, it can support that load. But when you are trying to bend the concrete, then it is very weak in tension. Due to tensile forces, when you are applying tensile forces on the concrete, it will get cracks. So for that purpose, we are adding the reinforcement, the steel bars in the concrete to make it strong in tension as well. Because concrete is good in compression, but weak in tension. So in order to increase the strength of the concrete in tension, we are providing the reinforcement, because the reinforcement is good in taking tension. Air content varies from 1 to 2%, depending upon your design strength or design quantities or desired qualities. Normal concrete is not durable against severe conditions. Normal concrete is not durable against severe condition. For example, freeze and thaw action or freezing and thawing. Hezbollah. Class number one, Hezbollah. 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 If you are not responding, I will give you -1 mark. Hezbollah. Okay, so Umar Hayat.
Yes, sir.
Uh, can you tell me about these things? That the normal concrete is not durable against severe conditions. For example, freeze and thaw action. What? Why? Why? जी बेटा.
Sir, I have no idea.
Okay, anyone in the class who can comment on this?
सर
I
मैं
will
करूँ?
give him one mark. जी बेटा, go ahead.
अगर हम पर्टिकुलरली फ्रीज एंड साइकिल के बारे में बात करें तो उसमें कंक्रीट में जो वो पानी होता है जब वो फ्रीज हो जाता है तो एक्सपैंड हो जाता है, जो जब उनका टेम्परेचर डिक्रीज हो जाता है तो वाटर में इनोमिनस बिहेवियर है कि वो वॉल्यूम उसका एक्सपैंड हो जाता है, तो उस वजह से वो एक्सपेंशन की वजह से उसका कंक्रीट में इंटरनल स्ट्रेस पैदा होता है, उस स्ट्रेस की वजह से वो क्रैक हो जाता है, इस वजह से ये ड्यूरेबिलिटी उसकी खराब हो जाती है।
Good, well done. I have given you one sessional mark. You are right. So, if you remember in this year and trend and mixtures, when I was explaining this year and trend and mixtures, I have explained this phenomena. In the normal concrete, we are not using ear and trend and mixtures because the ear and trend and mixtures they are making microscopic ear bubbles, and we will discuss this in the ear and trend concrete today in our lecture. So during this freeze and thaw action, as have explained by this Amir Hamza, the water convert the water is freezing, and once it is getting freezing, its volume increasing. Due to the increase in this volume, it causes stresses on the concrete, and when the concrete is in fresh state, it can cause cracks of the concrete. So in order to avoid these cracks, we are adding air and trend admixtures in the concrete, so that becomes a special type of concrete. So in the normal concrete, we are not using this type of admixtures, so that's why it is not durable against severe conditions. That is when the temperature is going below 0 degree C or into minus. The next one is the lightweight concrete. As it is clear from its name, the concrete which we are making in this, the concrete which have the aggregates of lightweight, then this type of concrete is known as lightweight concrete. The concrete which has substantially lower mass per unit volume than the concrete made of ordinary ingredients is known as lightweight concrete. In the lightweight concrete, we are using such materials which has lightweight. The aggregates used are lighter in weight. That's why the concrete made from this material is called lightweight concrete. The density of lightweight concrete varies from 240 kg per cubic meter to 1850 kg per cubic meter, or 15 pounds per cubic feet to 115 pounds per cubic feet. Strength of lightweight concrete varies from 7 megapascal, that is 1000 psi, to 5800 psi. Sometimes air and trend admixtures are also added to it, giving resistance to freezing and thaw action along with the strength. So in the lightweight concrete, if we are adding air and trend admixture, then we can make it resistance to the freeze and thaw action as well. Uses of lightweight concrete. Okay, so let me ask you people, Jalal Bashir, Jalal,
Yes, sir.
uh, where we can use this lightweight concrete?
Lightweight concrete. So, partly.
जी, Umar Hayat,
Yes, sir.
where we can use this lightweight concrete? What
Sir,
are the uses of lightweight concrete? Give it up.
sir, in dam we can use it, and other in sir we can use it in
And then, and
rising
then,
building,
then
sir.
वेट
Because
की वजह से हमें ज्यादा वेट चाहिए होता है.
जी sir,
Hmm?
in high rising building, sir, we can use because building is
Yeah,
so
in
heavy,
high rise building we can use this.
and also in dam we can use.
Okay, this can be used where extra load is not applied, because its strength will be less as compared to the normal weight concrete and the high density concrete or high performance concrete. So we can use this concrete in such places where extra load or maximum load or less load is applied. Okay, for example, parapet wall. I hope everybody knows the parapet wall. Maybe you have studied this in the building construction material in BCD course. Yes or no? Abdul
Yes,
Munaf?
sir.
Parapet wall, everybody is clear to everybody?
Yes, sir.
जी सर
Normally
Parapet
हम
हमें
एक
wall.
दीवार छत के ऊपर एक दीवार बनाते हैं, that is called parapet wall or पर्दा wall. Okay, so that is not, we are not applying load on that, so we can use this in the parapet walls. Road lining in between the two roads, because we are not applying load on that part of the road, so we can use this in the road lining, etc. Or to reduce the dead load of our earthquake resistant structures, as we can make the high rise buildings so that we can reduce the weight of the higher portions of the structures on the foundation. And similarly, as I told you, when you have high weight or heavy weight structures, then it will be having more probability to get damages during the earthquakes. When you have lightweight structures, then the probability of getting damages is very less as compared to heavyweight structures. So you can make,
Sir,
or you can use the light, एक मिनट, you can use this lightweight concrete in the earthquake resistant structures. जी बेटा आप बताएं.
सर कौन सा कंक्रीट है इकोनॉमिकल है, ये नॉर्मल और इकोनॉमिकल होता है ये वाला?
Okay, so if you can get this normal concrete is, as it is clear from its name, you can get the material very easily, normally available in the market. So that is more economical. And the lightweight concrete, you have to find some lightweight aggregates, or you have to bloat the aggregates, or you have to process the aggregates. So normally the normal weight concrete is the more economical than all other types of concrete. Okay, any other question? Okay, these are some natural lightweight aggregates. You can see the pumice, that is we are getting from the volcanic rocks, scoria, rice husk, sawdust when we are uh, cutting the wood or timber. So the dust we are getting from that, we can use that as also as uh, lightweight aggregates. And diatomite are, these are the types of natural lightweight aggregates. The next type is the high density concrete or the heavyweight concrete. Okay, so where we need this heavyweight concrete? Muhammad Ahmad?
सर डेम्स में.
हाँ बेटा.
सर डैम में ज्यादातर इस्तेमाल करते हैं.
हेवी वेट कंक्रीट डैम में ज्यादातर इस्तेमाल करते हैं. इसके अलावा दाऊद खान?
जी सर.
कहाँ पे यूज करते हैं हम हेवी वेट कंक्रीट?
सर जहाँ पर हमारे साथ ज्यादा स्ट्रेंथ रिक्वायर्ड होगी. जैसे कि सर ग्रेविटी.
Okay, so high density concrete is also known as heavyweight concrete. High density concrete is produced by replacing the ordinary aggregates by a material of higher specific gravity, normally about 4, compared with the specific gravity of ordinary aggregates of about 2.6. So the material which we are using in this, in making this concrete, having very high specific gravity. One of the more common natural aggregate is barium sulfate. It has a specific gravity of 4.1 and occurs as a natural rock with a purity of about 95%. Barytes behaves rather like ordinary crushed aggregate and does not present any special problem as proportion of mixes is concerned. So as I told you in one of our class that we have used this barite in one of our research work, and we have made very good concrete. With the help of this material, we have decreased the thickness of the wall which is required in the hospitals. So to protect the people in the hospitals from X-rays, gamma rays, at therapy centers and also in nuclear power plants, so that to protect the people from the radiation. So with the help of this barite, which we have which on which we have worked in the Department of Civil Engineering, with the help of some people in this Ernam hospital, and we have reduced the thickness of the wall from 18 inches to 9 inches if we are using barite. The high density concrete is used in the construction of radiation shielding, that is in nuclear power plants. The question of shielding results into protection against X-rays, gamma rays, and neutrons. As I told you, the biological hazards of radiation arise from the fact that the radiation interacts with the human tissues, losing some of their energy in this process. This energy loss is sufficient to ionize atoms in the cell, upsetting the delicate chemical balance and causing the death of the cells. If enough cells are affected, the organisms die. So, in order to protect the people from these hazards, uh, the civil engineers or the material engineers, they have done a very good job, and they have developed this heavy density concrete or high density concrete or heavy weight concrete, so that to protect the people in the hospitals and in the nuclear power plant. As you can see, these are the heavy weight concrete or high density concrete. Okay, the next one is the high performance concrete. Abdul Munaf,
Yes, sir.
can you tell me about the high performance concrete, as it is clear from its name? So can you comment on this?
सर जी, जहाँ पर हमें ज़्यादा कंक्रीट के परफॉर्मेंस दरकार होता है, तब सर हम ये कंक्रीट यूज़ करते हैं सर। और इसका जो लॉन्ग लाइफ है सर, वो ज़्यादा होता है सर।
Good, well done. Amir Hamda,
जी सर।
Amir Hamda, beta, can you comment? Can
किस
you
चीज़
add
पर
some
सर?
more? इसी पे हाई परफॉर्मेंस कंक्रीट पे।
नो सर।
Okay, Dawood Khan,
Yes, sir.
can you add some more comment? Can you help your friend Abdul
Yes,
Munaf?
sir.
Mm-hmm.
सर हाई परफॉर्मेंस की सर स्ट्रेंथ ज़्यादा होती है, एनवायरनमेंट एनवायरनमेंट जो हैजर्ड होता है उसके लिए रेजिस्टेंस ज़्यादा होती है सर, इसी वजह से ड्यूरेबल भी होती है, लाइफ टाइम भी इसका ज़्यादा होता है।
Okay, so the high performance concrete. This mix has the following main properties. कौन से? Number one, it has high strength, it has high workability, high durability, ease of placement. You can place it easily on site. Compaction without segregation. You can compact it with easily without having any segregation. The early strength of this concrete is high. The long-term mechanical properties, that is the tensile, that is the compressive strength, tensile strength, and flux strength are good. Permeability, it is impermeable, it is highly dense, and it have long life in severe environment. How we can prepare this type of concrete? The high strength concrete can be prepared with careful selection of ingredients and optimization of the mix design. So, so that the high workability is attained in this type of concrete by using superplasticizers. I hope you remember this from the admixture topic. They lower the water cement ratio because these are highly water reducing admixtures, and they lower the water cement ratio to 0.25, which is the amount required only for hydration process of the concrete. High durability is attributed or is achieved to uh, uh, high durability is attributed to fly ash and silica fume, which modify the mineralogy of the cement. We can use the fly ash and silica fume as well. Fly ash also increasing the workability of the concrete. Now let's talk about the silica fume. What is silica fume? Silica fume is a byproduct of producing silicon metal or ferrosilicon alloys. One of the most beneficial uses for silica fume is in concrete because of its chemical and physical properties. It is a very reactive pozzolan. Jalal, what is the meaning of pozzolan or pozzolanic material?
For those materials that have cementitious properties that replace cement.
Those materials,
that have cementitious properties.
yeah, when it is mixed with water in the presence of sodium hydroxide, then it has its cementitious properties. Concrete containing silica fume can have very high strength and can be very durable. Now the admixtures are 20 to 25% fly ash of partial replacement of cement, and rest of the 70% is ordinary Portland cement. So we can replace the cement with the help of this fly ash. It is not usually durable against freezing and time, so air and trained agents can also be utilized in making this high performance concrete. The strength of the high performance concrete varies from 10,000 psi to 15,000 psi. The water cement ratio can be reduced to 0.25 with the help of superplasticizers. Uh, the next topic is self-compacting concrete. Mansoor Khan?
Yes, sir.
As it is clear from its name, can you define the self-compacting concrete?
सर जिसको हम कंपैक्ट ना करें या जिसको कंपैक्ट करने की जरूरत ना हो
जरूरत ना हो मतलब खुद ब खुद उसकी कंपैक्शन हो जाती है.
यस
Okay, the concrete where no vibration or no vibrator is required. The concrete is compacted due to its own weight. It is also called self-consolidating concrete or self-compacting concrete, or it is also called flowing concrete. This self-consolidation concrete is characterized by extreme fluidity as measured by flow, typically between 650 to 750 millimeter on a flow table, rather than slump. We can measure the fluidity of this concrete with the help of flow table. We can't use this slump test for this for measuring this fluidity. No need for vibrators to compact the concrete, as we have discussed. Placement being easier, yes, you can very easily place it because it tries to reach to the location or to the required location by itself. No bleeding of water is taking place, and also no segregation is taking place. Uses and applications of self-concrete, where we can use this, why we need this. It is used in location which is unreachable for vibrations. You can't use the vibrator in those areas, for example, underground structures and deep wells. Also, and sometimes if we have very congested concrete, reinforcement, steel bars are very close to each other, then you can't use the vibrator in that place. So also you can try and you can use the self-compacting concrete. Uh, Bakhtar Shah, are you in the class?
Yes, sir.
Oh, Bakhtar Shah, you are in the class.
Ji, sir.
What is SCC?
Yes, sir, I am in the class.
SCC stands for?
What, sir?
This SCC.
सर ये reinforcement के क्या थे सर? SCC is a type of reinforcement sir और वो abbreviation बोल चुके.
अपना माइक बंद कर दे बहतर शाह. अब्दुल मुनाफ इनको बता दे SCC stands for. अब्दुल मुनाफ बेटा.
Sir, no idea about this term.
के बंदे self compacting concrete. SCC. SCC. Self compacting concrete can save up to 50% in labor costs due to 80% faster pouring and reduce wear and tear on the formwork. It can reduce the labor cost because you don't need vibrators, and it will reach to the desired location by itself, so you will need less labors. And also it reduces the wear and tear of the formwork because it is flowing very easily. The last type of the concrete in today's lectures, which we will be discussing, that is the entrained concrete. So already we have discussed this in our today discussion, that one of the greatest achievement in the field of concrete technology by the civil engineers or by the material engineers is the development of ear-entrained concrete. It is used where the concrete is vulnerable to freezing and thawing action. It is prepared by adding the ear-entraining admixtures. Ear-entraining concrete or ear-entrained concrete contains billions of microscopic ear bubbles or ear cells per cubic foot of the concrete. These air pockets relieve internal pressure on the concrete by providing teeny chambers or teeny places or teeny voids for the water to expand into these places or these voids or these pores when the water is freezing. And this will not cause the cracks of the concrete. So this is one of the big achievement of in the field of concrete technology. The other types of the concrete are roller compacted concrete, shotcreting, pervious concrete, and some other types of concrete. Jalal, what is this?
Study it by yourself.
Yeah, so when you go back to after the class, when you go back to your houses or to your apartments, try to read these types of concrete. Okay, these are very very important. Is there any question, beta, so far? If you have any question, you can ask.
सर आपने सेटिंग टाइम पर बात की कि सीमेंट फाइनेंस का इफेक्ट होता है और एयर में जो मॉइस्चर होता है उसका कैसे इफेक्ट होता है सर सेटिंग टाइम पर
Okay, yeah, this is a good question. Amir Hamza, can you answer this question, beta?
क्वेश्चन एक बार रिपीट करें.
If you remember, we discussed this in one of the slides that the over here, it has a sitting time of 30 to 90 minutes, depending upon the moisture in atmosphere and the fineness of cement. So how it can affect the sitting time of the concrete? If we have more moisture in the atmosphere, what will be the effect? And if we have more fine cement, then what will be effect on the sitting time of the concrete? It will be decreasing or it will be increasing?
सर जब मॉइस्चर ज़्यादा होगी तो सेटिंग टाइम वो डिले होगा क्योंकि नहीं सर तो जल्दी हो जाएगी. मॉइस्चर ज़्यादा होगी तो सीमेंट के लिए पानी अवेलेबल होगा तो हाइड्रेशन वो जो है सर वो हो जाएगा जल्दी. और इस तरह फाइनेंस ऑफ सीमेंट भी इसी तरह है कि जब फाइनेंस ज़्यादा होगी तो सरफेस एरिया उसका ज़्यादा होगा तो सरफेस एरिया जब ज़्यादा होगा तो अवेलेबल रिएक्शन के लिए अवेलेबल होगा तो भी रिएक्शन फास्ट होगा. हाइड्रेशन रिएक्शन और सेकेंड टाइम में वो कम हो जाएगा.
Okay, Abdul Munaf, can you comment on this?
सर जब ह्यूमिडिटी ज्यादा होती है तो सर सिटिंग टाइम डिले होता है सर, और जब ह्यूमिडिटी कम होता है सर तो फिर सिटिंग टाइम जल्दी हो जाते हैं सर.
What about the fineness?
सर जब फाइनेंस ज्यादा हो जाते हैं सर तो हाइड्रेशन रिएक्शन जल्दी हो जाते हैं और सर सिटिंग टाइम जल्दी हो जाते हैं सर. और फाइनेंस कम होता है सर तो हाइड्रेशन रिएक्शन टाइम लेते हैं और सर इस
This
तरह
was a
फिर
good
सिटिंग
question.
टाइम.
So when you, after the class, go back and study these things. If still you have any problem, then you can ask me again. Okay. After this class, go and study these things in the books. This is very very easy. But if still you have problem, I'm not going to answer this. Already we have cleared this. Some of your class fellows have already cleared this. So when you go back after the class, read this in the book. If still you have some problem, you can ask me. Is it okay, Daud Khan?
ओके सर.
Okay, any other question, beta? Any other question, beta? Okay, so Hizbullah has asked a question that what is pre-stress concrete? So if you remember, I have explained this in the class. And normally in the bridges, we are trying to pre-stress the sections or the girders. So we are trying to produce some stress uh, in the section. And let's you have this section or this is the girder. Then we are using some tendons some tendons, or and then we lock on one side this tendon, and from the other side we are applying stresses. Okay, we are making tight this tendon. So when we are making tight this tendon, what will happen? This surface will come like this. It will go up. It will go up like this. Or let me make a bit. Daud Khan, can you see this page? दाऊद खान,
जी सर,
ये पेज नजर आ रहा है आपको?
थोड़ा नीचे है सर।
ओके,
पेज नीचे
नाउ
की।
अब नजर आ रहा है?
यस सर।
Okay, so this page, on one side you can see over here, if we have made this from concrete, then we are applying a tendon on this. उसके लिए हमने अपनी जगह छोड़ी होती है, and then we lock from this side, and यहाँ से हम क्या करते हैं कि यहाँ से हम उसमें forces, stresses apply करते हैं, and when we are applying stresses in this, what happened to this page? It becomes like this. It becomes like this. नजर आ रहा है अभी बेटा?
थोड़ा ऊपर करें सर पेज।
Is it okay?
Yes sir.
It bends like this, and when we are applying the forces, it can take more forces, because when you are applying forces from the top, first it will come to its original shape like this. Okay, and then it will bend, and then it will bend. Okay, so these are called, this type of concrete is known as pre-stressed concrete. Okay, any other question, beta? If you have no question, then we have Viva of group number 6. So only group number 6 students are requested to stay in the class, or बाकी लोग they can leave the class. Thank you very much.